I bet they had tons of great stories. That just to live in that time, in that era, just seeing everything that changed so fast. And
I love looking at the old images through different buildings, whether it's in New York City or wherever it is, of old buildings being built and people up in skyscrapers. And you're right, so many people have lost their lives, and it's just an engineering masterpiece seeing how some of these buildings are created.
The funny thing about that, because I was thinking about this earlier, is just like the fact that human ingenuity, when people actually decide to work together on something and it's more than just like two people, you can really do a lot of stuff. Like when you get a whole entire like nation or even like an entire like country together to do one specific task, you guys kind of take it to a whole new level of completion. Because if you told me, like if I was in school right now, you told me we made it to the moon with that technology from back then, that little bit of technology that I have more on my phone than that, I would find it very hard to believe. I'd be like, where's your sites? Like, cite me this. Like,
I'm changing my answer to the moon landing. Because I'm remembering now that like a lot of that math and stuff was done, those calculations were done by hand.
Yep.
Oh my gosh, especially with space travel, like one calculation off could ruin everything. Like I am scared to ever have to be in a situation where like, hey Jay, an asteroid's coming at us. You have to calculate this thing. And I'm gonna be like, well, we're just screwed. We're just gonna have to die.
That's where the peer review process comes in.
That was all done on a calculator with less power than your handheld.
Yes. What is that movie? There's a movie that came out not long ago with Kevin Costner in it.
Was that Calculations by chance? It was the movie about the NASA, the code writers.
Yes, it was a really good movie.
What was the lady's name?
I don't remember.
I totally thought you were going to say Hidden Figures.
Yeah,
that one. Hidden Figures.
Exactly.
That's the one.
Yeah. Okay. Oh yeah.
Hidden Figures. That was a good movie. That was really good.
And it was basically true. So.
Yeah, and
that had several inspirational story themes inside of it.
It did. It really did. One of the biggest inspirational stories inside of it was measure your door before you buy a computer.
Guilty.
Yeah, I mean, it's kind of how it works.
It's happened to me. Measure your stairwell before you try to get your couch up it.
I've never had that problem as of yet.
Yeah, I've had problems like that. It wasn't long ago I had to take out my daughter's window in order to get stuff in my basement. But it worked.
I don't even have a basement.
I'm in my basement. This is where I live most of the time now. Mm-hmm. So, we've talked about some of the coolest things we've seen engineered. How about some of the coolest things that we've engineered or created?
Like personal favorites?
Yes, personal favorites.
That's always a hard question. It's like, what is my favorite?
Yeah, especially like, have you seen my profile? I have.
It's kind of like going into a job interview and saying, "Well, what are your weaknesses?" Oh man,
see, they're right behind me, and if I say something, they're all going to be, "Oh no, why did they pick me?"
See, I don't think that's the problem for me. Is the fact that my favorites change depending on what's happening. So, like. My favorite, top of my head, I'm definitely going to say like my goggles or like my glasses here. That's the moving parts and stuff. Like I love this type of stuff. It's just fun. It's goofy. It's totally characteristic, which I love. I love that. But like, if you tell me like pick your favorite like robot, I'm gonna have a problem because I got like several of those and I can't really just choose one without having the others feel left out and I feel guilty. So. You gotta give me more on that.
I guess if I had to pick a favorite one, I would say this jetpack back here. I took a jet engine that's from like a very expensive RC airplane world and attached it to my back to see how fast I could roller skate. And I kind of pushed myself. Zach Friedman, who I love on YouTube, he has this quote. He said, "We do these things not because they are easy, but because we thought they would be easy." And so if you set a goal, like I bought this jet engine, I'm like, okay, I got to use this in a project now. I had to get better at welding. I had to learn some new math that I had never done before. I had to understand things about jet engines that I really didn't understand as well as I thought I did before. And it pushed me to learn a lot. And also the video, because nobody died, it turned out really good.
What do you mean? I mean, a lot of people are not doing the Brooklyn Bridge. Sad, rest in peace. But at the same time, the most interesting things happen when things unexpected happen.
Right.
I've caused many fires, burnt down many things. I accidentally made fun fact, I was trying to actually make spiderweb fluid from like Spider-Man using like silly string and stuff like that. And my chemistry project worked, but then it started eating through the wall. So I accidentally made silly string acid. So yeah.
That's like a
things
spider person superpower then, right?
Mhm.
Right.
The funny thing about it, it was cool, but like I didn't refrigerate it, so it kind of like got really hard. I just never built it again because after having to try to fix my wall, which is still not the best looking wall right now, yeah.
Well, I usually make stuff that's like only sticks around my apartment and it's shown off on like, you know, at like a table at Maker Faire or something like that, but doesn't often leave the immediate vicinity. But one time I worked with some friends at my hackerspace on a mini golf hole that was part of a artist-made mini golf course on Governor's Island. And that was really fun. I was really proud of that because people got to interact with it. And it was a time when I made something that had to be really durable. We had to install it Memorial Day weekend, and then it had to stay all summer and not be taken down until August. And so like outdoor paint, children climbing on it, like, and it had to be a playable golf hole. So it wasn't my initial idea, but I did do a lot of the engineering for the CNC plywood robot that we use to cut out the pieces. It's a cross section of a human cell. So you roll the golf ball around the different bodies inside the cell, and the way you kick the ball off is through a ramp that it looks like a microscope.
So like the mitochondria and the Golgi apparatus. And...
Exactly. Yeah. Are the obstacles in the mini golf. And depending on where you come out, there's 3 levels of difficulty, 3 little ramps. And then, so we had to like practice play it, which is really fun. And then, we CNC wood cut the pieces and laminated them together. It was just like a really fun, feel good group project. And then we did get to destroy it at the end, but it did hold up really well, like especially compared to the other ones.
That sure beats a windmill.
Yeah, right.
It's a much better mini golf course themed, I don't know, hole or whatever you want to call it, but that's way better than a windmill.
Oh, yeah.
The theme for the show was about, I think, like scale. Mini is the new big or something like that. So we were going really small, but there were some that were like a gigantic USB phone charger, stuff like that. I don't know. It was fun.
Cool.
Yeah.
How about you, Rob? What is something you've built that's really cool?
So one of the fun projects I worked on a few years ago, we're kind of like, so it looks like a little gun.
Yes, I love this project.
Yep, I have a little FLIR sensor on here so you can see essentially a thermal energy around you, and I stuck it on a DLP projector so you could walk around and you could actually see the heat energy broadcast on the wall. And so
cool.
It was kind of a fun project.
Cool, yeah.
And the DLP doesn't have much IR spillover, so it doesn't mess with the sensor?
Nope, not at all. I think this one's actually laser driven too, so it doesn't add a lot of heat, but you touch the wall and there's your handprint.
Mm-hmm.
And so the main goal is just to walk around and find, in our case, up north, it's always cold, so you're trying to find the coldest area. What's leaking.
So it makes the invisible visible. You're saying in that case,
So you just shine at the wall, and it would read the FI with the FLIR sensor, and it would broadcast what it is.
So Rob made that a couple of years ago now, and I know you've made some new iterations and made it better and better and better. But we brought it to a few different maker fairs and shows, and we ended up saying, Rob, you got to create more of these. Because all of a sudden we have 2 shows at once and everybody wants to see it and everyone wants to play with it. And then we get worried that it's going to, be an electronics device and fail, which it never failed. So we always wanted extras and spares because it's such a fun piece to talk about.
Do you have a name for that project, Rob?
The FLIR gun.
Okay.
I mean, it's a good name.
I like it.
And we designed it so it looked exactly like a drill, which are FAA approved, so therefore just stick in your luggage.
I like it. I thought you might go for is it hot or not?
No, we never really had an official name. It was like, it's a couple random parts. It seems to work.
It's like that. Is it hot or not? That's good.
Rob, I should talk to you later. One of the ideas I haven't gotten to in my notebook is using a DLP or another kind of projector, but replacing the light source with instead of visible light, using infrared light, because
Nice.
your smartphone cameras, most of them, if they don't have the IR filter, can see that, and you can project hidden messages, which I love. Hidden messages, love it. You put like a riddle on the back of a, Leonardo da Vinci painting, you've got me for the next 2 hours.
It'd be a perfect prop for a mystery room where you'd have an invisible thing projected at the wall, like get the right lens out.
Mm-hmm.
Yeah, because inside these, you could pull the laser out and do your own stuff. So it's just a bunch of mirrors.
That sounds like the kind of thing I would have loved at my childhood birthday parties. Way better than pin the tail on the donkey.
Yeah. So that brings up a good point. What is something you want to make? What is kind of on your bucket list of things to engineer?
I have a very long list.
Let's see. Consult's long list.
Let me just give me a second. Let me just
Opens new tab.
One of the things I work at this house is I've got a bunch of solar panels in the backyard. I'm trying to get a whole bunch of these server farms because I have all these Beagle Bones and they're all on AC power. It's like I'm trying to get them all on solar, but if you look around for solar converters, it's either really high end stuff or really low end stuff. So it's like as I put in parts together, like some of this I can just make. So I'm just trying to solar my house. Essentially, is one of my projects.
Now, for those, you can just go direct to DC, right? You can go DC to DC converter.
Or you get a 12-volt ATX power supply for your server. So the goal is, how many solar panels you need, and then just getting all that energy to the house somehow. Because there's really expensive options and there's really cheap options, but there's nothing in the middle that just works. That you can
there's some lower end MPPT, maximum peak power point trackers. That include a charging circuit for like 12-volt lead acid batteries on Amazon. I was helping a student find some recently, just for like in the $100 to $200 range. Yep. Then you buy the panel, and then you buy the battery. Is that considered the low end for you, or would that be like a good range?
Yeah, that's at the low end. But what I've noticed, a lot of those aren't documented what they do, and like I want to change the points. So it's like, because I got 2 batteries out there right now for one thing, and it's so cold it drops it down. Like I want to raise that point so it shuts off earlier, but you can't. So it's like I want to control my batteries in solar.
Oh, but can it be fixed? Like, can you just replace the NTC or whatever the thermistor is?
I haven't opened it up to look yet. I bet I could, but right now
you seem like the kind of guy that opens it up.
To a point, but then it stops. It's like they give you a little bit of wiggle room, but not what I want.
Okay.
Because when you're doing 40 below with batteries, like I don't want to drop to 24. I want to keep it 25, 26. It's got to keep it fully charged, otherwise, batteries die.
Right. Yeah. Very fast when it's very cold out.
I wouldn't know that.
Can you bury them under the ground, really far under the ground?
You would have to
go 8 feet down. We could do that. But then you have to dig the hole.
In the summer.
Yeah, and then if the water floods and the battery's underwater.
Oh.
Yeah.
Oh,
everybody to Rob's house. Bring your shovels.
Post-hole.
These are these moments where I'm glad I just don't live anywhere near the cold. You guys can have the cold. The cold is all you. I'm staying where it's heat and summer all the time and fires. That's fine. I'm staying here.
Well, wait, where is there just fire? Are you on a volcanic island?
No, it's called California.
That kind of. I'm sorry, I forgot.
What is an island?
You forgot that California is a fire hellscape.
Yeah, I live near these huge Great Lakes, and I forget sometimes that parts of the world are on fire.
I have the best of both worlds. It gets both cold and hot here, but in Minnesota it gets just as hot, but also colder. So I think y'all
beat a wide range of temperature changes.
This morning the air temperature was minus 27. And that's not counting any wind chill or anything like that. It was just brutal.
But there was not one single mosquito.
That's true. There was
I hate mosquitoes. That's great.
Well, I'll share my next project, and there's a couple I'm working on right now. One is I'm making some computer vision code that tracks flying objects and predicts their trajectories. And the purpose is to predict the trajectory of fruit that has been lobbed through the air. And so like, what's the next step? I'm not like just predicting the trajectory of the fruit, right? No, you want to make a robotic arm. If I can find one that maybe a company will let me borrow, or you can make like at least a carriage with like a rotary, at least a 2 degree of freedom kind of mechanism and then you attach a sword to it so that you can track the fruit lob through the air and fruit ninja it in real time. That's a worthy challenge. I'm looking forward to that.
I remember in physics class in high school doing something where we calculated the trajectory of a ping pong ball or something. We had a launcher, and we had to move the cup. It had could fire with a certain amount of force, and we had to calculate where to put the cup to catch the ball. And I remember that really making calculus click for me for the first time. I learned calculus, and I was like, "What is this math? Okay, fine, whatever." Derivatives. And then when we were calculating the trajectory, and I'm like, "Oh, you take the derivative of that to find the curve for the
parabola
for the calculation." And like, okay, so calculus is useful for figuring out where things land. Nobody told me that until physics class. Like nobody bothered to tell me that in calculus at all, that it had this like relation to real world, because a lot of math doesn't. So I don't know. I wish more teachers were more interdisciplinary and were able to articulate what things are useful for in order to grab students in different ways. Because I certainly wasn't motivated by the pure math, but I was super motivated by the ball launcher.
Yeah, that's when I give K-12 talks. Typically, my theme, because I guess I'm not creative and I use the same theme every time, is to show projects and to show like some of the cool, sizzle reel parts of the videos, and then get the kids excited, and then break out. Okay, now here's the notebook. Like here's the math, here's the equations, here's the circuits. So when you're sitting in your math class and you're thinking, when am I ever going to need this? Well, if you want to design a computerized waterfall with an attached swing set, or if you want to design a musical Tesla coil, these things are really useful. You need them.
Yeah, I get that. I like to go backwards when it comes to projects like that. I like to be like, this is the cool thing I built, and then let's show it in action. How do I do that? These steps here. I feel like once you described it a little bit better of like, you use this and this and this to make this cool thing, it's a lot better than just going from, you'll use this eventually. Like, show them a reason why they would use it. One of my best teachers was actually a history teacher, and he showed us, we played pretty much throw water balloons at each other, but we did it in an old school World War I style where we had to stand in lines and then like throw a ball. And then if you got hit, you have to go to the back. And then everyone else would step forward, and kept doing that over and over again. So we're out of water balloons. But it stuck with me, and it was the best way for us to learn how the original World War was fought, because that's exactly what it was. A whole bunch of just little Muppets just, and if you miss, you just got to sit there and just go again.
So Steve in the comments actually made a really good point. He's been teaching his calc students that they've been doing this kind of calculation in their head since learning how to catch and throw a ball or cross the street without getting hit by a car. And that's really a good way to get people to understand, like, this stuff. So it's pretty cool. I still think, Ian, you would impress me if you could create your Fruit Ninja chopping machine. I don't remember exactly how you worded it. If I could throw a grape and it would cut it in half.
Yeah, grapes. And that's actually a fun part of engineering, is that if you can't get things to work to the accuracy that you need, changing what it says on the spec sheet, suddenly it's good. I can't do a grape. Well, how about a lime? How about a grapefruit? Okay, a durian.
I'm familiar with adjusting the sliders on your triangle of like accurate and fast and good.
Mm-hmm.
The only thing I'm currently working on is improving. I'm working on a whole bunch of projects that I'm not ready to say, but I am working on improving my programming skills for AI. So I'm working on a personal AI, currently Mycroft. I've been editing it and then learning more about it because I have a theory, which is going to sound insane, but hear me out. So I've listened to a whole bunch of audiobooks, and one of the stories I listened to, one of the characters put his consciousness into one of the machines. And the way he did this is he didn't really digitize his brain or anything like that. He just kept a whole bunch of audio diaries going, and he was teaching the robot to be him. So it's not really him, but the robot thinks it's him and actually like thinks like him too. So I kind of want to try that. Like, I'm working on a way where I can actually teach my robot using a whole bunch, because I do audio diaries too. I'm that person who talks to the camera and get used to it better. So I want to try that. Like, I really want to try and like make an AI system and teach it to like be me per se, especially because I rarely use my first name at all. So I think that'd be a hilarious wake word. So That's my mad genius idea. I want to try it. I want to see the psychological effects about it. I want to take it to my mom and be like, hey, I digitized my brain. So this is me now. It'll go to all your family events because I don't want to go.
Maybe it'll rescue you someday from some kind of horrible prison. Did you see that episode of Black Mirror with Miley Cyrus? That was the plot. There was a toy that had the AI of her downloaded into it, and like it helped solve crime.
See, like I don't know where this is going to go, but I know it's going to be fun, and I know it's going to look cool. So
yeah, I'm excited for that. I want one. I want a mini Jay.
What I like about modern day engineering is just what you said, Jay. This is really interesting, and I want to try it. The thing is anybody can. Like you look 20 years ago, if you're trying to create some kind of an embedded design, you're talking of thousands, if not hundreds of thousands of dollars just to create an embedded design, to get all the software you need, the programming package, the debug software, and all the different things that you need. It's a lot of money. Where now you can get a fully functioning computer for $15.
Oh yeah.
And you can really, try. Like you said, Jay, you can try anything you want because there's open source. The open source hardware association has made things so amazing to be able to, share your code and help everybody. And the community is just great.
Oh yeah, that's
what I love about modern day engineering.
It's
Definitely
so easy to find mechanical assemblies of almost anything too.
Yeah.
If you want to build something with something, like go down in a warehouse.
That's something I've been thinking about constantly because the way my brain thinks is I think all this is fun. This is play for me. Like I'm at that point in my life where I get to do what I want and it's just kicks and giggles. I forget that I'm working half the time. It's legitimately being like, I just love doing this. And then the thing is, not a lot of people have that like type of mindset where they just think of like science and just the fun of thought. It's fun. Like my favorite classic story is Alice in Wonderland. Why? Because nothing makes sense and it's just fun. I think of 7 impossibilities in the morning and try to build like 8 by brunch. It's just kicks and giggles. You don't have to take everything so seriously. Just build it because you want to build it. Make it because you want to make it. Make it because it's fun.
Right. So moving on to the next question I have, and Ian, you kind of set the stage for this question is, can you talk about a time when you had to accept failure as an option? Because that's very common in engineering. And then, obviously it created a learning opportunity and, maybe helped something or some way.
It's like,
wait, y'all can do that?
Failure?
That's a thing? You could do that? Somebody didn't tell me. I must have missed that week. I didn't know that was a possibility.
I don't know. I fail so often. I don't even. It doesn't. I try not to make it traumatize me anymore. So I'm trying to remember even.
It's not really failing either.
Because it's just like a part of the iteration process, right?
Yeah, like what's the definition of failure in this case? Like, do you mean failure as in like just give up full-heartedly, or failure as in like taking a step back and being like, okay, I can't make it do all the things I want. Let's focus on what we can make it do and reorganize how we do this.
I'd say what's a learning opportunity?
Give up. We just Well, this way didn't work. Well, you just learned. Let's try it this way. I mean, we don't just throw in the towel. That's not what humans do.
We kind of suck at that. Like our entire species going through like centuries of years, we kind of suck at giving up.
Right.
I guess I've done some experiments that didn't pan out. Like I tried to attach some LEDs to some plastic coated with indium tin oxide, ITO. It's that stuff that is used for the touchscreen on stuff. And so it's clear, but it's conductive. I scored a line through the coating and I put the LED across the line and I used conductive paint to attach it, and I used alligator clips, and like they lit up, but they wouldn't stay. Like, of course, the paint is not glue, and like, it wasn't useful for anything but just a fun experiment. And I think that's, I guess I didn't think of it as a failure. I just thought of it as an experiment that didn't really go anywhere because I didn't have any expectations either. So I don't know.
I mean,
I think it is important to know though when to give up on something. One of the groups I'm involved with is a musical Tesla coil group called the Tesla Orchestra, based out of Cleveland. And we typically do shows, and we've spent enough time worrying that things go flawlessly. But this one time we were trying to record a demo video for America's Got Talent, and we had an idea to do an illusion. And the idea was stellar, and we spent So much time. We made a prop flying system. We had a trapdoor. We had a curtain that was a CO2 curtain. So you just see a white cloud due to the moisture content in the air freezing. All this cool sciencey stuff to produce an illusion. And we were down to the wire on the space we had rented, and we just ran out of time. Things were breaking. It was like 4 a.m. We're supposed to be out of there the next day. We hit the Tesla coils, and we blew up or destroyed a lighting controller. And it got to 5, 6, 7 a.m. and we realized this isn't going to happen. And the past couple months the output is a terrible, sad learning experience. And it is important to know when to throw in the towel so that you can move on to projects that are more fruitful, that are going to be more valuable.
Yeah, I see that. The most recent thing definitely with me was like my wing shoe project, because originally I wanted an accelerometer to move the wing for me. That way, when I was walking, the wing would pop up, and then when I stopped walking, the wing would go down. That worked for like one day. When I actually took it out to my parents' house to test it, I noticed that I had to really like bend my foot while walking, kind of like if you're rollerblading type of like motion to actually make the wing like stay up. And also it was like super huge and like just way too big for like the shoe that I wanted anyway. So I ran into so many errors that I just got to a point of me having to be like, okay, this is not going to work. Let's take a step back and let's keep the same concept but make it work in a different manner. And that's how I got the idea of having it be a soft switch where I can just touch my heels together and the wing just flies up, because it's just cute that way. But like, yeah, I told my first plan didn't work, so I went with plan B. I had a plan C and D plan too, but luckily I didn't have to go that way.
You can also, something I employ a lot is if my project only works 80% as well as I intended it to, I can just describe the problem and what I would do differently. Because, when you're making content for others to consume online, like they want to know how to insert themselves anyway. They want to see themselves in the project anyway. So if they're like, oh, well, I could do that better, then that's kind of inspiring to a certain subset of people who think they can do better, and then are motivated to do so because they didn't see it realized the way that they think would be ideal. So I look at failure that way too, but it's when I am struggling to, I made a mirror that tells you nice things, and I wanted it to pull from the internet, but I was just having all this trouble with the code. So for the video launch, it didn't do that. But then with help from other people who saw the project, I could then make the code work. So by saying what you need help with, you can make new friends.
Oh yeah, definitely reaching out for help is such a big help. Like if anyone watching this in the future or present, if you need help, don't be afraid to ask the internet or ask a friend, because I love being confused and being like, oh, let me just ask the Twitter brain, hey guys, I need help with this. And I get a whole bunch of comments of like how I can make it work. Or I even like message my friends. Like I message Sean for like coding help sometimes. I'm just like, hey, what are you doing right now? Let's go on a hack and snack. Let's just chat a bit while you help me with my code.
Yeah, I completely agree with that. Like the whole community around engineering and making and creating is just amazing. And everybody is so great. And if you ever, like you said, Jay, if you need help, they're there. Like I know different companies have different chat areas where you can go in and ask questions, and a lot of times they'll just completely blow up, and it's great.
Yeah, and I think that's what's different about making. Like somebody who is a couple generations older might say, why do you call this making? This is engineering, this is science. Why do you use this new term to discuss? People have been making things for tens of thousands since the beginning of humans. That's what differentiates us from a lot of the other species out there, is that we make things, we make tools, we use them. And so why call it making? And I think that the difference between, say, my dad's generation, who attached lawnmower engines to bicycles to terrorize their neighbors, and my generation, where I, put like a jet engine on my back to terrorize my dad, basically, is that we can go online. Like we're not limited to asking our neighbors for advice or people we met through school for advice. Our network is, 6-7 billion people. It's as big as we can imagine. I think that's that online community, which can be very helpful, is what makes it different, why we call it, why it's earned a new word.
Yeah, I agree with it. all my basic skills I learned from making. That's why my personal rule is like when I get really old and gray, have my gray dreads and everything, and I'm a master maker. I want to have like at least 100 projects out on the internet because my whole thing is like open source. And even if I don't make it open source right away, eventually I'm going to publish it because that's how I learned. And even like a small step of like me learning like how an accelerometer work, that might work for somebody else that's trying to figure out how to get that to work. Just giving back to the community in small ways like that, just from helping your project, is just great, in my opinion.
Yeah, it is great. Sorry, go ahead, Rob.
As I was going to say that, like, engineers kind of got a bad stigma, and so like the makers are like, this is our social network. This is what we like to do. We want to show people what we can do, what we've done, and we want other people to learn from it and just expand on it. It's like, here's a project I did. Here's all the data. Go have fun doing it. I enjoyed making it for you. Do whatever you want with it. And I think that's just the engineering brain. But we just call ourselves makers.
I prefer the term tinker, but that's just because of a book I read a long time ago. But I don't really like calling the term engineer because I know a lot of people had to go through hard schooling and hard math classes to earn that degree. So I always just call myself just a simple tinker. And then that way I feel like it also brings off some of the pressure of being an engineer, because once you're an engineer, a lot of people just assume that you can build anything. Aren't you an engineer though?
Well, the whole point of the degree was to learn how to learn. That was the whole point of the degree. And so if you don't get the degree, but you've already learned how to keep learning continuously, that is an engineer.
Oh, that's how that works.
Because not every engineer goes everywhere else. They never do the same exact thing as someone else. Their goal in life is just, well, I need to do this, and I need to figure out how to do this.
Right.
Yeah, the only times when, and Becky mentioned this earlier, there are some niche times if you're designing a bridge that you need to have a professional engineering, a PE or a structural engineer, an SE certification. And in that case, it would be wrong of me to say I'm a professional engineer because that's a specific term. But with or without an engineering degree, if you're practicing engineering, if you're doing design, build, verify type processes, you're closing the loop, or you have a sensor and then a servo and it's doing something. That's the act of engineering.
So I do like this comment really quick before we move on to the next question. I'm going to pull it up on the screen here. Some makers are great and scary at the same time. And that's so true. And I'm one of those that's great and scary at the same time. I'm not an engineer. I'm a maker. I have like I said, I have an electronics degree, and I've done some pretty stupid things. One of them, not like I built my own project, but just a simple thing. I was replacing the battery on an iPhone at my desk inside Digi-Key, and it started on fire. That was a fun
place. That's a perfect place for the fire to happen, though.
And Kevin is great with a soldering iron too. We should say he can see those.
I also had a close call with a lithium battery, but it just got bulgy. It didn't catch on fire. I did cover it with a wastebasket and then had to check and was like, no, there was no fire. So
funny thing about that. Actually, once you finish first, sorry.
I was just gonna say, yeah, I panicked. I grabbed the thing and ran outside. It was wintertime, so I threw it in a snowbank. Ran down the stairs, the thing smoking in my hand, burned my hand, and then I came back up and there's this plume of smoke. I'm never gonna forget the VP. I sat right next to the VP at the time, and he walked by and goes, "What's that smell?" And just kept walking. It was just like, it was just great.
It's
one of the
smell of engineering.
Yeah,
smell of science.
And thanks, David Sandys, in the comment, and your volunteer.
Yeah, I literally. I want to build something one day. Like, I'm still learning about PCBs, and one of the PCBs I want to build is definitely going to be a power converter. But if I could use some stuff from like Tiny ML to make it more like voice command, I want to make a self-destruct feature. But all I really wanted to do was turn off everything with the lithium-ion battery, just roast everything.
There's a self-destruct thumb drive you can buy, and I'm very tempted. It's pricey, but if you Google for self-destruct,
yeah, I've seen that before. I want to do that.
It does the thing.
But it's like you only use it once on your laptop. It's like,
yeah.
Well,
you use it once, you can't do it again and again and again.
Moral of the story: look around and find your nearest fire extinguisher, and if you don't see one, get one for your workspace.
Right. Yep.
in my defense, I got the idea after one of my robots was almost stolen. So I was like, how to fix this problem? Oh, what happens if I have to look for a robot and just scream out a command and the robot just ignites? So,
That's good. There's not enough people that know who Inspector Gadget is.
Oh, I love
Spoiler
Tim.
alert for my Halloween costume. I'm finally going to try to do Penny's computer book.
Oh, really?
Penny.
oh,
That's awesome.
Although my partner is very tall and I'm very short, so it really works out. He's a really good Inspector Gadget.
And you have a dog.
And I do have a
Oh, yeah,
dog.
you
Yeah.
have a dog. Yeah.
So the next question I have, and this is probably may wrap up our time here, because I think there's a lot of really good ideas in this question. How can people encourage kids to get more involved in engineering? I mean, I do know a number of kids that if you lead them in the right direction, it's fantastic watching what they can do, because the kids these days are so smart. And it's really amazing. But how to point them in that right direction and try to get them off of social media for a little while to do something and create something. So what do you guys think?
I could offer. Oh, go ahead, Jay.
Personally, I think the way of Becky Stern is the best way, which sounds very weird, but for YouTube, because I have nephews, I don't have any kids of my own. I let my siblings decide to have kids, and I just become the awesome Uncle Strange. So
Same.
when I see them, and I always show up and do stuff, and I'm ordering them Pokemon cards. His birthday is coming next week, but every time I come up, he wants to build something or make something, and he got all this knowledge from YouTube. I got him some spray paint recently because I just wanted to show them how to spray paint. And he tried to spray paint some water, and then tried to do that little electromagnetic drip where you put it in the water, and then in case the color pulls out. He tried to do that with spray paint, and I was like, "Where did you learn that from?" He's like, "Oh, YouTube." And I was like, "Wrong stuff, but right idea."
Hydro dipping. I've seen spray paint hydro dipping. Yeah.
Yep.
Cool.
Jenna Marbles
He was
did it
trying
4
to do
times
that
tops.
out of nowhere because he saw it on YouTube, and I was just like, "What have you been watching on YouTube?" Takes thing. Whole bunch of tutorials.
Yeah, so
on
I agree. I don't think social media is so bad, Kevin, to keep the kids on, as long as the kids are watching stuff on social media that is.
I would agree.
For...
I completely agree. If you can channel in the right area, there's TikTok is amazing. Really, if you use it the right way, the stuff people post on there it's amazing.
Well, that's why I said the level of Becky Stern, because I feel like the best way to do it is to make it entertaining for kids, but don't make it so not cringy. But don't make it for where they feel insulted by watching it. Because I've noticed some shows, and even my nephews get bored with these type of shows, where they try to make it so little kid friendly, or to a point where they're just I'm not interested in this. But yet they've watched full episodes of Futurama and fully watched the episode and really be into it. And I'm just maybe there's a thin line of balancing out kid friendly education and then just education.
Yeah, I teach grad school, so I teach grown-ups, and I don't pretend to be comfortable in a room full of smaller youngsters younger than that. But I know that when you can see it, you can be it, right? So my whole thing about encouraging young people is that just show them people they can relate to doing stuff that matters, that they care about in these fields. So watching interviews, I love Business Insider, and there's other YouTube channels that interview people in cool jobs. I know Mike Rowe and his old Dirty Jobs show, that was great, and as an example of what I'm talking about, just talking to people who are actually doing this stuff about why they like doing this stuff, to show that there is a person like me doing on a boat doing science, or on a volcano doing engineering, or because until you see that person you relate to, you don't realize how disconnected you feel from those things.
Mythbusters Jr. was great. I loved watching that show.
Yeah, that was a good one.
And we work really close with Ali Weber, who was on that show, and she was fantastic.
That's great.
I've also like Carrie Roberts. Oh, sorry, no, go.
Sorry, Jay. I've got a couple suggestions. There's a number of really cool science and engineering kits out there now. KiwiCo is one of them that maybe has the most brand name recognition. And getting those as a subscription service where you get a box and you put together something with your nephew, niece, son, daughter, etc. Those are really inspiring these days. Also, there's a variety of summer camps that you can get young people involved with. One of them that I volunteer at is called Beam Camp, Beam like laser beam. And it's a camp where you get to make stuff. There's a lot of fun, a lot of creativity. You make your own games. They build these huge sculptures out in the woods in New Hampshire. It's really cool. And the last thing I would say is to let young people who are interested in making things, let them make things, even if you think it's not going to work. It's okay to experience those kind of failures. I think one of the things that makes me most excited to learn a bit of math is when I've done something at a level that was too basic to have ever worked, and I realize, you know what, there's another level of math, there's another level of science that I need to learn here. On YouTube, Veritasium uses this really well. I think Derek from Veritasium did his PhD on this. He doesn't just come out and tell you, did you know that, what's an example, all of the carbon content in a tree came from CO2. He doesn't start with the end result. He starts with the thing that's going to inspire you to be curious about it, inspire you to care. He says, where did all the mass in the tree come from? And people make these guesses. Did it come from the soil? Did it come from the sun? Somehow, I don't know. No, and you start to care about the answer. And so I think letting young people try things, even if you think it's not going to work or it's not going to be really professional, is very valuable to their development.
I believe it was Neil deGrasse Tyson who said in Star Talk that you just let your kid be curious, like let them experiment. Like you might think it's silly and you might think it's dumb or something like that, but let them like go jump in puddles and see how the puddle reacts. Let them go look at things and play with it. Just let them be curious.
Right. I think that's a big one. Let them be curious.
100% on that. That's definitely.
Mm-hmm.
Just let them learn on the, let them see the world.
Like curious to a point, like putting two metal objects in an outlet is probably not the right kind of curious.
I learned that when I was 4 years old.
Yeah.
I had some grad students who hadn't learned that yet. So, it's never too late to learn the basics. There's no stupid questions. That's what the breaker is for.
So, funny story with that, just really quick. My daughter, she was at the time probably 3, talking, but not great. And she was in bed, we thought. And all of a sudden, she started screaming. She ran out in the living room and fell on the floor and was could not talk, could not breathe. And finally, we got her settled down and she said, fire, and pointed to her room. And I ran in there and the power was out. And finally got everything kind of figured out, got a flashlight. Before I had turned the power on, she had took a necklace and put it over an outlet, like a charger for an iPad, but it was sticking out just a little bit. So she crossed, the 2 leads, and it sparked. There's a big black spot up the wall, and poor kid. She didn't get hurt, luckily.
I did the same thing when I was a kid. It wasn't a necklace, but it was something. I did the exact same thing. I was probably 7.
Never did that. My first taste of electricity was shocking myself, and honestly, I have to say, thought it was going to hurt worse.
Who had an older brother who made them lick a 9-volt battery? That's inspiring somebody to get into engineering.
Definitely.
I have one right now. Should we just go ahead and go for it?
That's how I tell my grad students that they're not going to electrocute themselves with Arduinos. I'm like, look, if it's a 9-volt battery, the circuit you're making is 5 volts.
I tell it to my kids too when they're worried about some USB light in their room starting on fire. I'm like, it's 5 volts. It's not going to happen.
Yeah, so it's 100 milliamps. It'll be fine.
Right.
I mean, honestly, if they want to, you can just have a day outside where you just show them how to use a fire extinguisher and just light some stuff on fire and just, this is how you use a fire extinguisher. So when you see fires, this is what you do.
That sounds
it must be fun to have you as an uncle, Jay.
The funny thing about it, literally, my dad has my nephews call me Uncle Strange because my dad thinks everything I do is strange, and they've grasped a hold of that title for me. So having me as an uncle is I'm going to let you have fun. I'm going to support all your stuff, but I'm going to make sure you do it in a very safe way. And I'm also going to really hype you up with sugar and stuff, and then give you back to your mom when I'm tired of you. I literally pick them up now when I leave. It's a ritual now. I just pick them up and just give them to my sister. These belong to you. Return in the sender, and I'll catch y'all next time.
Oh, you can still pick them up. That's nice. My nephew's about a foot taller than me.
When they become taller than me, I'm going to be a little annoyed because I'm the tallest. Don't become taller than me. I have one good thing in this family. That's my height. We have it.
You're being modest. You got a lot of good things, Jay.
Right. Well, we are at our 1 hour point. Does anybody have anything they'd like to say as we sign off? I would just like to say, engineering is amazing. I think engineering is not slowing down anywhere. We see it in the industry. There's chip shortages. There's shortages everywhere you look, but in the engineering and electronics world, we're seeing a lot, and that's a good and a bad thing. We know that things are being used and they're being produced, and it's a lot of fun right now to be in the engineering industry and in this world, and being able to being able to 3D print, being able to play around with things without hurting yourself, hopefully.
Or just slightly.
Yeah.
I mean, if it doesn't kill you, it gives you 5+ resistance.
Yeah, it's all about those stats.
Yeah.
So level up.
That's right.
You definitely end up leveling up, because I couldn't. You told me to build the stuff that I built now 5 years ago, and now I look at you like you're weird and be like, I don't know how to do any of that. Where do I begin?
Yeah, you can't imagine what the jobs are of the future, right? I went into school thinking like, I don't know what I want to do, but this is what I'm interested in. And then like, lo and behold, like a job made itself that didn't exist when I was in school. So that's good to keep in mind, that like, there's still a lot of new jobs that don't exist yet. And you don't have to pick one that already exists.
And I'm a walking example of that. I went to school to draw. I was supposed to be drawing comics the rest of my life. I have an art degree that's weighing down a whole bunch of mail that I don't even look at half the time. But it doesn't mean you can't do something else. Like, my art degree powers make me come up with cool designs.
Exactly. That's very true. There's a lot of different areas of the world that work that way. Art and electronics go together, just like clothing and electronics go together. Wearables. I mean, Becky, you do a lot of wearables, and that goes together. It works.
There's things aren't getting less integrated, right? Like now designers I teach in a product design grad program, and the designers, they're not just making like a 3D form. They're making something that has electronics inside it and maybe an app. And so like these cross-disciplinary teams are what's required to make the future we all are thinking of, right?
Right. Even in sports. I mean, look at all the technology in sports and football helmets, hockey helmets.
Oh, yeah.
It's everywhere. So it's great. Engineering and technology is an amazing place to be.
My future has more.
With that, if anyone else has anything they'd like to add, otherwise we'll call it a day. Call it a great show. You guys, Jay, Ian, Becky, Rob, thank you so much on behalf of Digi-Key for joining us. And happy National Engineers Week.
Fun.
Thanks, Kevin. Thanks, Digi-Key.
All right. Thanks, everybody. Thanks, everybody, for listening in.
Bye. Are we not live?